Today we're going to move to the graphs of secant, cosecant, tangent, and cotangent. And we're going to start with the cosecant graph. We know that cosecant is just the reciprocal of sine. So what we're going to do is we're going to, on the same graph as sine, graph all the reciprocal values of the sine values. So for instance, if I'm at 0, what is the reciprocal of 0? Well, the reciprocal of 0 is undefined, so I'm going to put an asymptote wherever I have values of 0. So this is an asymptotic line. Here I have another value of 0, and I'm going to put another asymptote. And everywhere there's a value of 0, I'm going to put an asymptote. Now notice on this graph, I'm graphing from negative 2 pi to positive 2 pi, which is actually, which is actually 2 periods. And we'll usually only graph 1 period. Then I'm going to graph all the reciprocals of 1 and negative 1. So if we take a look, here's the value of 1 at pi over 2 for sine. Its reciprocal is also 1. The reciprocal of negative 1 is negative 1. Likewise, here we have negative 1, and here we have negative 1. All right. Now here's the trickier part. I need to graph all the other reciprocals of the values of sine. For instance, if I have this as a value of 1/2, its reciprocal is 2. Well, if this is the value of 1, the value of 2 is over here. Likewise, here is another value of 1/2, and here's a reciprocal of 2. So this blue graph is going to be the graph of secant. Now over here, I have values of negative 1/2. Negative 2 would be down here. So once again, you'll see that the blue graph is the graph of cosecant. And I usually never go ahead and memorize the cosecant graph. I usually just look to find the graph of sine and find all of its reciprocals. So that's how I'll be going about it today. Now, down at the left here, we're going to talk about the domain and the range of this function. Well, the domain is all the x values that exist. Well, the only x values that don't exist are my asymptote values. Now, where do those happen? Well, I've got a pattern here. Here's one at 0, pi, 2 pi. So it looks like the domain is all reals not equal to pi and all multiples of pi. So I'm going to say pi k, where k is a multiple or an integer value. So anytime I multiply that, we're good to go. The range is all the possible y values. Now you see the blue goes up forever and down forever, but it stops at 1 in the upper portion and it stops at negative 1 in the lower portion. So I can say the range goes from negative infinity to negative 1, and that's included in union with 1 to infinity. And that's my range. Let's look at the next graph. We're going to now graph secant, which is the reciprocal of cosine. So again, everywhere I see a 0 goes an asymptote. So here's my first at pi over 2. I have another at 3 pi over 2, not a very straight line. Another at negative pi over 2. Another at negative 3 pi over 2. I'm going to take now and graph all my reciprocal values of 1 and negative 1, just like I did in the previous example. And then I'm going to take all my reciprocals of 2 and negative 2 for the half values. So here's 2 up here, here's another one, here's another one. Draw these. And then all my reciprocals of negative 2 somewhere down here and here. So again, the green graph is going to be my graph of secant. And there's two periods in there, you'll notice, because it goes down and up and down, and then starts down and up again over to here. So secant has, once again, a value, period value of 2 pi. As well as cosecant did. The domain in this case, well, notice this time I have, instead of values of pi, I have values of pi over 2 as my asymptotes. So the domain will not equal pi over 2 plus, well, my next asymptote is 3 pi over 2. That's pi away from pi over 2. So any pi multiple thereafter added to pi over 2. Y values very similar to the last one. We go from negative infinity to negative 1 in union with 1 to infinity. So now we're going to graph tangent. And we're going to go back to a similar method of graphing this that we did with our sine and cosine earlier, a couple lectures ago. We're going to take and go from 0 to 360. And we're going to look at those special axes points, because those have simple values of x and y in which to calculate sine and cosine. We know that tangents equal to sine over cosine, or y over x. So I'm going to graph my y over x values from 0 to 360. If I look at the value of 0, and I look at the y value over the x value, that's 0 over 1. Happens to be 0. If I go to 90 degrees, and I have an x value of 0 and a y value of 1, and I put y over x, I get an undefined term. At 180, I get 0 over negative 1, which is 0. At 270, I get negative 1 over 0, again, undefined. And at 360, I should get the same value as 0 because they're coterminal. Now, I'm kind of stuck because I can't connect dots since I have these asymptotes. So I'm going to find another point where it's easy to calculate a tangent value. Well, I know at 45 degrees I have root 2 over 2 and root 2 over 2, which means my tangent value is just 1. So at 45 degrees I have a tangent value of 1. Therefore, my tangent goes up here and approaches this asymptote. Over at 135 degrees, which is somewhere down here, I'm going to also have root 2 over 2 and root 2 over 2, except in this case, my x value is negative. Therefore, I have a negative 1 for my tangent value. So my tangent looks similar to this. And if I did the same for that 45-degree value between 270 and 360, here's my graph. Now, you'll notice in this case, tangent starts at 0, goes up, hits this asymptote, starts down, goes back up again, and you'll notice this area here is the same as this area here, which means it repeats. So this tells us the period of tangent is 180 degrees, or pi if I'm talking radians. And that's going to be important. So domain, well, my domain is everything but my asymptotes once again, so that's going to happen at 90 plus any addition of 180 thereafter. So any addition of 180 no matter how many times. My range, notice it goes up forever and down forever, and no breaks in between, is all reals. Let's take a look at cotangent. And cotangent is a reciprocal of tangent, so it's cosine over sine, or in this case, x over y. We're going to graph this once again from 0 to 360. Look at all those important axis points, 90, 180, 270, 360, etc. And we're going to take our values from the unit circle once again. So at 0 degrees, I'm going to take my x value over my y value. That happens to be undefined because my y value is 0. I get 0 at 90 degrees. Once again, undefined at 180. 0 at 270. And again, undefined at 360. Again, I'm out of luck because in this case, I don't have any dots to connect. So I'm going to look at my 45 and 135 points here. And I notice that at 45 degrees, my cotangent, or my x over y value, is 1. And at 135, I get negative 1. So therefore, once again, I connect those dots. And you'll notice my cotangent looks something like this, similar to tangent, but not quite. You'll notice tan always rises and cotan always falls. Now, again, the period for cotangent is 180 degrees or pi. The domain is going to be any multiple of 180. So 180n is where I will get asymptotes, so it doesn't equal any of those. And my range, once again, is all reals. So let's graph a couple of these with period changes and phase shifts. Once again, this is not in our standard form. We're going to do that by factoring. This is the cosecant. I'm going to pull my 2 out. I'm left with theta plus pi over 6. Therefore, my period is 2 pi over the k value, which is 2. So my period is pi. I have a phase shift of pi over 6 to the left. And I have an interval value of pi over 4. So I notice if I'm going to start at pi over 6 back and move up by pi over 4 every time, I'm going to make my intervals into twelfths. So this is 2 pi over 6, or 2 pi, sorry, 2 pi over 12. And this is 3 pi over 12 for my intervals. So here we go. I'm going to back up to negative 2 pi over 12. And I'm going to add 3 pi over 12 every time. Adding 3 pi over 12 gives me pi over 12. Add 3 more to that, I get 4 pi over 12, 7 pi over 12, and 10 pi over 12. We said our period was pi, so there should be 12 pi over 12s between the start and the end, and there is. Great, I can graph one period of cosecant now in this period of time. So here's what I'm going to do. Like I said before, I don't bother to know what cosecant looks like. I just know cosecant is 1 over the sine. So I'm going to graph a sine graph first. Sine starts out at 0, goes to 1, 0, negative 1, 0. And so here's my sine graph. And this is what I use as a base to graph my cosecant. It's really bad. Now what I'm going to do is I'm going to take and graph cosecant, which is basically just the reciprocal. So everywhere I have 0, I have asymptotes. Here, here, and here. Those are my asymptote lines. Then I'm going to take all my reciprocals of 1 and negative 1. Then I'm going to find out where I'd have roughly a half. That's 1 and that's negative 1, a half somewhere around here. So that gets me a reciprocal of 2. And here's my negative halves. So here's my reciprocals of negative 2. And then I just connect the dots. And there we have it, our graph of cosecant with the proper translations and phase shift changes. So here's a graph of secant with an amplitude change, a vertical translation, and a phase shift. I have a phase shift of pi over 4 to the right, vertical translation of 1, and that's up, and I have an amplitude of 2, but since it's negative, I'm going to flip. So let's take again and think about, well, what are my intervals? My intervals are my period. The period in this case is 2 pi because the k value is 1 over 4. So I'm still going to label from pi over 2 on. Now you'll notice once again my phase shift is pi over 4 back, but my intervals in this case are pi over 2. So I'm going to, instead of pi over 2, use force. So that's 2 pi over 4. I'll start at pi over 4 and move 2 pi over 4 every interval. So that's 3 pi over 4, 5 pi over 4, 7 pi over 4, and 9 pi over 4. And when I'm done, I should have 2 pi or 8 pi over 4 in between my start and my end, and that's what I've got. We're going to graph a midline of 1 up. So if this is 1 and negative 1, my midline is going to be right at 1. And if I was to graph my cosine value from here, all right, I would go up and down 2 because that's my amplitude. However, instead of starting at a cosine, this is 1 over cosine again, at a cosine of 2 up, I'd start at a cosine of 2 down. 2 down puts me at negative 1. Then I go back to my midline. Up 2 from there puts me at 3. Back to the midline and back down. This would be my cosine graph. However, I'm not trying to graph cosine, I'm trying to graph secant. So let's go ahead and do that. Everywhere I see a midline value or a value of 0, I'm going to have an asymptote. So that's here and here. Now, every place I see a resembling value of 1, I'm going to take its reciprocal. All right, this is kind of like a value of 1 even though it's at 3. And I'm going to find the reciprocal of all these values. So I'm just going to flip this guy on its head. Like so. And just to make sure I got this right, I'm going to check one of these points. I'll check 5 pi over 4 and 3 and make sure that exists in this graph. So here we go. I take negative 2 times the secant of 5 pi over 4 minus pi over 4, and then I'm going to add 1 to that. So this is negative 2 times the secant of 4 pi over 4, which is pi, I'm going to add 1 to that. So the secant of pi is the reciprocal of the cosine of pi. The cosine of pi is -1. Take the reciprocal of -1, and I get -1. And I'm going to add that to 1. -2 times -1 is +2, plus 1 is 3, and this checks. So now we're going to take and graph tangent. And this is going to have a vertical translation and a phase shift. My phase shift is pi/2. It's to the right. A vertical translation is 2 going down. I'm going to go forward pi/2. My intervals in this case, notice this is a little bit different. My period for pi, or I'm sorry, my period for tangent is equal to pi. Now, when I look at my unit circle, I normally take my period and divide that by 4 because I have 4 equal quadrants in a period of 2 pi. However, right now, my period is only pi, so I'm going from 0 to pi. Now, within that moment in time, I have 2 quadrants, 1, 2. So rather than taking my period and dividing it by 4, I'm going to take my period and divide it by 2 for tangent and cotangent. So pi/2 is going to be my interval values. So if I start at pi/2, my next pi/2 is pi, and my next pi/2 is 3 pi/2. And you'll notice between the start and the end of this, I have values that have a difference of pi, which is my period. Now, normally, at my first interval value, I have a tangent value of 0. In this case, we have a translation of the midline down to 2. So, if I go down to -2, I'm going to create a midline from here. So here's my new midline. Tangent value usually for the first interval is 0. Then at the next interval, I typically have an asymptote. So I'm going to put that there. Next value, I'm on my midline. Then tangent consistently rises, so I'm going to go up and then down. Okay, now a little bit harder to check a point here, but we can still do it. We'll check the point 3 pi/2 and -2. If I take the tangent of 3 pi/2 minus pi/2, and I subtract 2 from that, then I get the tangent of pi minus 2. Well, the tangent of pi is my y/x value, and I know at 3 pi/2 minus pi, I get 2 pi/2, which is pi. At pi, I get values of -1 and 0, so my y/x value is 0 minus 2, which is, whoops, -2. And it checks out, so I'm all good. I think we've got 1 or 2 more examples for you. Cotangent, once again, I'm going to put this in the proper form. This is a cotangent, pull out a 3. I'm left with theta minus pi/9, yuck, And in this case, my period is going to be equal to pi over k, since the period of tangent is only pi. So in this case, I have pi over 3 for my period. My phase shift is equal to pi over 9 to the right. My intervals, since I have cotangent and my period is only pi, is going to be the period value, which is pi over 3. And since I'm only talking now about half a circle, I divide by 2 to get my interval. So I have pi over 6 for my intervals. Notice once again I have a phase shift of pi over 9 here, pi over 6 here. I probably want to match those up and go 18ths, I'd say. So this is 2 pi over 18 for my phase shift, and this is 3 pi over 18 for my intervals. So I'm going to again graph this. I look and I start at 2 pi over 18. I only have to go a distance of pi in 2 intervals. So I add 3 pi over 18 to that, which gets me 5 pi over 18. I add 3 more pi over 18, and what do I get? I get 8 pi over 18. I need a pi over 3 distance between these two. I notice I have 6 pi over 18, which is pi over 3, so I'm gold. Now, cotangent, we know, normally has an asymptote at its first interval. So what I'm going to do is I'm going to draw in an asymptote here. It also has an asymptote at its last interval. Oops. Drawing an asymptote there. There is no vertical translation. Also, we know that cotangent usually at its second interval has a value of 0. I'm going to then say cotangent falls the whole time, draw the graph, pick a point, and check it. So I have 3 times 5 pi over 18. Subtract pi over 3 from that, and take the cotangent of that value. I have a value here of 15 over 18, which is, what is that, 5/6? 5 pi over 6 minus 2 pi over 6. And I'm finding the cotangent of 3 pi over 6, or pi over 2. Cotangent of pi over 2 is 0, and we've checked it out. Couple more. Last one, we're going to write the equation of a cotangent function with a period of 5 pi over 6 and a phase shift of pi over 4 to the right with a vertical translation of 3 up. So first thing I'm going to deal with is the period. I know 5 pi over 6 is my period, and that's equal to, since it's a cotangent function, pi over k. Solve for k, so that's pi over 5 pi over 6, or 6/5 equaling my k value. I have a phase shift of pi over 4, and that's to the right. So therefore, I know I have y equals my cotangent. I'm going to put my k value of 6/5 in parentheses. I'm going to go theta minus my phase shift, pi over 4, inside, and then I have a translation of 3 units up. So outside, I'm going to add 3, and that'll take care of it. Another long one, sorry about that, but here are your questions for today. This is the first question. just multiple choice. And here are your second and third. We'll see you tomorrow.